mynews.studio.
Hidden within the immune system, there are cells quietly making life or death decisions. Recent Nobel-winning research suggests we might finally be able to help millions living with autoimmune conditions by understanding these peacekeeper cells.
Today is November 27th, 2025. Let's start with the main story. 3 scientists, Mary Brunkow, Fred Ransdell, and Shimon Sakaguchi, have been awarded the Nobel Prize in Medicine. Their discoveries have changed how we think about autoimmune disease. What exactly did they find?
Their research answers a long-standing question. Why does our immune system, meant to protect us, usually avoid attacking our own tissues? For decades, immunologists wondered why diseases like type 1 diabetes or lupus aren't more common. The key, it turns out, is a group of cells called regulatory T cells, or Tregs. These act as brakes for the immune system.
So this isn't a small adjustment in our understanding, it's a real shift. Let's walk through how this unfolded. Sakaguchi played a foundational role back in the 1990s, right?
Exactly. In 1995, most researchers believed immune tolerance was set during development in the thymus, a concept known as central tolerance. But Sakaguchi ran experiments where he transferred T cells from healthy mice into mice without a thymus. Surprisingly, those mice didn't get sick, which meant something else was maintaining immune balance.
And that something else turned out to be Tregs. What makes these cells so important?
Tregs operate like referees for the immune system. They prevent the immune response from becoming too aggressive and attacking the body's own tissues. Sakaguchi's findings were published in the Journal of Immunology, and though there was initial skepticism, the evidence was strong. Tregs are now considered a cornerstone of immunology.
But that wasn't the whole story. It took another 6 years for Brunkow and Ramsdell to find a crucial link, the FOXP3 gene.
Right. They were studying a mouse strain called scurfy that developed severe autoimmune disease. By analyzing over 170 million DNA base pairs, they discovered a tiny 2-letter deletion in a gene they named FOXP3. This gene encodes a transcription factor that essentially programs Tregs.
And mutations in FOXP3 weren't just found in mice. In people, errors in this gene lead to a serious autoimmune illness called IPEX syndrome. So, this gene bridges the gap between animal research and human health.
Exactly. Then, in 2003, Sakaguchi showed that by turning on FOXP3, scientists could convert other T cells into Tregs. It's like flipping a genetic switch to create these peacekeeping cells when needed.
That's the science. But what does this mean for patients? Are there treatments available now? Or is this still mostly experimental?
Right now, there are over 200 clinical trials underway based on these discoveries. Some experts think new therapies could arrive within 3 to 5 years for conditions like rheumatoid arthritis, multiple sclerosis, Crohn's disease, type 1 diabetes, and lupus. Researchers are also looking at Treg-based therapies for transplant patients and even for use in cancer immunotherapy.
So instead of broadly suppressing the immune system with today's drugs, we might soon be able to fine-tune it, calming only the parts that are overactive.
That's the hope. Rather than using treatments that leave patients vulnerable to infections, these therapies would adjust the immune response, either increasing or reducing it as needed. For transplant recipients, this could mean preventing graft versus host disease without risking rejection of the new organ.
This also opens up possibilities for personalized medicine. If we can identify who has issues with their Tregs or FOXP3 function, could we intervene before disease even appears?
That's one of the major goals. Early intervention or even prevention could be possible, especially in children with a genetic risk. It's a move from managing symptoms to addressing the root cause.
And there's a broader impact. Autoimmune diseases are increasing worldwide, costing billions in healthcare and lost productivity. Even if only some of these therapies succeed, they could make a significant difference.
It's not limited to autoimmune illness. Cancer researchers have found that tumors can recruit Tregs to stop the immune system from attacking them. If we can control Tregs, we might help the immune system target cancer more effectively.
So the same discovery, regulatory T cells, could be used to either calm the immune system in one disease or activate it in another. Finding the right balance is key.
Now, the challenge is turning this science into real, affordable treatments. That involves more research, new ways to manufacture these therapies, and ensuring they're accessible around the world, not just in wealthier countries.
In summary, decades of research are now fueling hundreds of clinical trials, with the real possibility of transforming lives. The Nobel-winning work behind Tregs and FOXP3 shows that basic science can lead to important medical advances.
From the mystery of why our immune system spares our own organs to the possibility of new treatments for millions. This is science making a tangible difference.
Thank you for joining us. This episode was brought to you by mynews.studio. Give it a try for free.